All right, I want to take a look at the graph of the cotangent now, and I'll do it in a way very similar to the tangent, recognizing that the cotangent of x is the cosine of x divided by the sine of x. I'm also going to look at it as 1 over the tangent of x, but right now I want to look at this. I'm going to draw 3 graphs, all the same one. I'm going to draw sine of x here to start with in blue. Remember the sine is period 2 pi, so there's 2 pi, and there's pi, and there's minus pi, and there's minus 2 pi. And so that one was in blue. Let's see, in green now, I'm going to draw cosine. So I'll put these dots in to make sure that I got this lined up right with the sine. So there we go. So there's a reasonably decent cosine curve. And in red, we'll draw the cotangent. Okay. The cotangent is the cosine divided by the sine. So whenever the cosine is equal to 0, so is the cotangent. Right? The tangent lined up with the sine for x-intercepts. Now the cotangent is lining up with the cosine. So there's the x-intercepts of the cotangent. And the vertical asymptotes are determined by when the sine is 0. So vertical asymptotes will happen here at 0, here at pi, and at 2 pi. And cosine, every place the sine is 0, the cotangent will have a vertical asymptote. Now when I look at these fractions here, sine over cosine, when they're both positive, the cotangent will be positive. When one's positive and one's negative, then we're negative. When they're both negative, it's positive again. When one's positive and one's negative, it's negative. Anyway, and there you have your cotangent curve. It looks a lot like the tangent, although it's upside down. Yeah, intercepts in the same place as the cosine, vertical asymptotes where the sine has intercepts. Okay. Let me look at this in terms of the reciprocal of the tangent. Actually, let's do this on the graphing calculator. So this was the tangent graph that we had from the last video. I want to go up here and change that function, clear that one out, please, and put in the cotangent instead. Cotangent of x. Save that. Let's look at the graph. Now, this is what we just saw. The cotangent is matching the cosine for x-intercepts. And when the sine is 0, you've got those vertical asymptotes. Okay. How are the cotangent and the tangent playing together here? So let me put one more graph in here, and if it's too busy, I'll take some out. But in purple, let's put the tangent back in. Okay, put the tangent back in, save that, draw the graph. Wow, okay, there's a lot of graphs in there. But notice that purple one's the tangent. That when the tangent is small, the cotangent is big. And when the tangent is big, the cotangent is small. They're reciprocals of each other, right? Right here is that spot at pi over 4 where they cross. Both of them are at the same elevation. The sine and cosine are at the top. That's the pi over 4 gives you a 1, both for the tangent and the cotangent. But I can see the reciprocal nature of tangent and cotangent here. That when tangent is small, the reciprocal is big. When tangent is big, the reciprocal is small. So the times when the tangent is headed up toward infinity at the asymptote, the reciprocal is headed towards 0. Okay. So anyway, there's tangent and cotangent, reciprocals of each other, but both very closely related to sine and cosine. Right? There you go.